Alright, so this question says the graph of the line y equals 6x minus 5 intersects the graph of the parabola y equals x squared at 2 points. So it's asking for the distance between those 2 points, and we need to express our answer in simplest radical form. Alright, so whenever I see this system, these intersections, the first thing I want to do is graph this to see, well, what does this look like, right? So if we were to draw our coordinate axes, there we go. And then let's draw out the line y equals 6x minus 5. So it has a positive slope, negative y-intercept, something like that. And then we have y equals x squared. So that's just our basic parabola that goes to the origin and curves back up. So it would look something like this, and it would intersect twice, of course. I don't know where they would intersect. That's what we need to find algebraically. But it would look something like that. And then we're just looking for the distance between these 2 points, which will, of course, be on that line, which is helpful. So in any case, how are we going to find where these 2 points, these 2 graphs, they intersect? Well, where they intersect, the x and y coordinates have to be the same. So let's take our y coordinate for this line and plug it into y for the parabola. So we're substituting 6x minus 5 equals x squared. It's just a system of equations, just like you do when you're doing 2 lines, except now we just have a line and a parabola. So we can bring this 6x minus 5 to the right side to get x squared minus 6x plus 5, which factors into x minus 5, x minus 1. And so now we find that our x coordinates are 1 and 5. So now for the corresponding y components. Okay, so this is simple. We already have our x components, and since we know the y components are going to be the same, we could either plug it into y equals 6x minus 5, or we could plug it into y equals x squared. So since I think y equals x squared is a little simpler, I'm going to do that. And so for x coordinate of 5, we get y equals 5 squared, or 25. So that's this coordinate right here. And then for our x coordinate of 1, we get that y equals 1 squared, or just 1. And we would get the same exact answer if we were to plug it into y equals 6x minus 5. So now that we have our 2 coordinates, we need to find the distance between those 2 points. And so how are we going to do that? Well, most people would go ahead and just plug this into the distance formula, which there is nothing wrong with, right? But I kind of just want to break this into horizontal and vertical components and treat it like it's a right triangle, right? Because we know we're going right 4 to get from 1 to 5. And then we know we're going up 24. At least we should be. I know this graph is not great. We're going right 4 and up 24. And our distance is just going to be the hypotenuse of that triangle that these horizontal and vertical distances form. So if we were to scale this triangle down by 4, we would get triangle 1, 6, making our hypotenuse the square root of 1 squared plus 6 squared, which is 37. And so scaling this back up, we would get that the hypotenuse of this triangle is 4 root 37, meaning that the distance between these 2 points is 4 squared root 37.